to start now. Yes. Okay, this is CSC161 Advanced Java. We're looking at sorting starting this week. The first sort that we're going to look at is the bubble sort. And we're going to look at the bubble sort through use of some playing cards, which you should be able to see. Y'all give me a confirmation again. Are y'all seeing the cards okay?
Yes.
Yep.
Okay. Well, you know what? I hope so. I'm not sure how that's going to go on the recording, but we'll find out. Okay, so anyway, for a bubble sort, here's the idea.
Is he gone?
Hello?
Oh no, this is not going well.
He goes, you know what? And disappears.
Bye.
Who left? Did I leave? Oh, God.
You are muted, but you are back.
Well, this recording isn't going quite to plan. So, all right. I just have to reshoot this one too. Let's just go ahead while I've got y'all and finish this thing out. Okay. The idea of the bubble sort is you work your way from first to last. You take a look at the card you're at and the one next to it. If they need to be swapped, they're swapped. Move up one. If they need to be swapped, swap. Move up one, and you go all the way to the end. That first pass through only guarantees you the highest card is at the end. Now, it could be, like y'all saw when this was still going, that the cards accidentally fall into order just because they were partially in order to start with. So that's a downside if you just run a straight bubble sort, because there's nothing that checks to see if that card has been, if any cards have been swapped. And that's the whole deal. If you can make it from one end to the other without having to swap any of the cards, you're sorted. Okay, so it's called the bubble sort. To me, it's a backwards name, because for me, if you shake up a jar of soapy water and then watch the bubbles, you'll see bubbles start to make their way to the top. And I've always noticed that the little ones work their way through and show up at the top. But before it's all over, the big ones are up there. So anyway, that's how it gets its name, is the cards are kind of bubbling up to the top of the deck. And you'll wind up with the smallest ones on the left, biggest ones on the right. So what I would like to do is go ahead and code this for you. Now I just edit the whole thing. So let me get us through tonight, and then we'll go from there. Do you have ability? Y'all know how to take screenshots on your machines? Everybody can do that?
Yep.
Yep.
Okay. All right. After I get the code up here in solid, then I'll let you know, and everybody can take a snapshot of it, and then you'll have a copy of what to start with. And then you don't have to wait for me to try to do the video on this thing. Okay, so let's see, we're still recording on this. I'll go ahead then and share my screen with you. And it's the Eclipse screen. Okay, so everybody see my Eclipse screen okay?
Yeah.
Okay.
Yeah. Yep.
And the second question is, can you read the code that's there? If not, I will make it larger.
Yeah, I can read it.
Yeah, I can read it.
Okay, I'm not getting a request to make it larger, so I'll leave it like that. Okay. So I want to try to do in code what we just did with the cards. And so I'm going to start up here. First thing I'm going to do on this one, I'm just going to give myself some numbers to work with. Usually in all of the sorts, when you're learning the sorts, the data you work with is just plain integer data. The reason being it's the easiest one to mess with. And we're trying to learn the process of the sort and not, okay, how do you refer to this string? And no, we're just trying to learn the sort. So I'll start off with an integer array. and I'll call it list, and that's going to be equal to, and I can fill it in as we go right here. So I'm going to have 1, 39, 3, 3, 151, 76, 1, 123, 97, 15, and that'll be enough. Okay, so that's what I wish to put in order, and I'm going to do it using the bubble sort. So the first thing I'm going to do is just turn around and print it out so I can see it how it was to start with. So I'm going to do a sysout. Oh, would help if I got it on the next line. Let me, okay. I'm going to do a sysout, control space. Really? Like I said, I'm on a brand new machine, so there's some things that aren't ready. System.out.print and drop down a line. Now what? Oh, thank you. Okay, I appreciate that help too. System.out.print and drop down a line. And what I'm going to print is a message that says list in original order. Okay, and need a semicolon at the end of the line. Okay, let's see. So next line is, oh, I just want to print the numbers. Okay, so what I'm going to do, I'm going to want to do this 2 or 3 times. So I'm just going to create a function that does it, and I'm just going to call the function and hand it the list. So I'm going to say print list, and that is not a Java command. I've got to create this in a minute, and I'll hand it the list to print. Okay, and then I'm going to call the sort, which is going to be a bubble sort. So I guess I could go ahead. I called it sort in my code, but I think I'll call it bubble sort. Bubble sort. Well, wrong one. LESORT, and I'm going to sort the list. Okay, and then when I get through with that, I want to print it in its new order. So I'm just going to copy and paste here. Copy that and paste it down here. And this is list in sorted order is all I have to change. Okay, and again, I have to create the functions print list and bubble sort. So I'll create those. As a matter of fact, that's all this code is supposed to do. So I'll take out that extra space. Now I want both print list and bubble sort outside of main, but within public class bubble sort. So I'm going to come to right about here and drop down a couple of lines. So I'm outside of main, but I'm within bubble sort. Okay, so let's do the first one, which is the print list, and that'll be public static void print list. And what I have been handed is an array list, is a list or an array of integers. So I'll say what I'm going to expect to be handed is an integer array. And now then I can call it anything I want to in here, and I'll just refer to it as values. All right, so there's a point that needs to be made, and I don't know if we've done it anywhere else in the class, so I'm going to do it right now. If I call a method, whatever it is, and hand it X and Y, then what Java does, it goes and finds the value for X and hands it down, finds the value for Y and hands it down, and then whatever you called now has a duplicate. So when you call a function with X and Y, you're not working with the original X and Y, you're working with duplicates. So in your function, you can do anything you want to X and Y, and when it's over with, X and Y are unchanged. Okay, that's why you have to return changes back. When it comes to an array, whenever you call a function and give it only the name of the array, and remember, list represents 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different values. So instead of Java trying to hand down a copy of the array, Java hands down the memory address of where that array is stored. So up here on line 8, when I say print list, okay, well, I come down to print list. I am handing to print list the address of this array, and print list is going to say, all right, I'm expecting the address of an integer array, and I shall refer to that address as values. At this moment, values and list are synonyms for each other. They both point to the exact same spot in memory. So down here, when I do print list, if I make any changes to the list, I'm making changes to the originals, not a copy of them, but I am changing the originals. So that's something you need to keep in mind. You will use that fact a lot in Java. If any of you move over into C++, Java does this and doesn't tell us about it. C++, you have to request that specifically to have it happen. So anyway, here we are. So I have been given the original list, and what I would like to do is just print them all out. So I'm going to say 4, and I'll create a new integer called x, and I'll start it off at 0. And then I'll say I want to keep running x as long as it is less than how many ever we've got in the list. So this would be values, dot length. Okay, so if there's 10 elements in the list, which there are, then values dot length is 10. So this says for x equals 0, as long as x is less than 10, okay? X is less than values dot length. And I want to up x by 1 every time at the end of the loop. Okay, so what do I wish to do? Well, I'm going through these one at a time. So I'm just going to do a good old print. Let me see if it'll do it yet. Sys out control space. Hey, it caught on. Okay, finally. All right, and all I'm going to do is print out an element of the array, and the array is referred to as values, and the element that I wish to print out is whatever value is in x. So the first time through the for loop, this will be value sub 0. Come around again, value sub 2. And remember, our subscripts will run 0 to 9. So when we're printing out our last one, value sub 9, and we come back around into the for loop, we add 1 to x. X is now 10, and x is no longer less than the values dot length, and it stops. Okay, so got that there. Let's see, so that's my print. That's all I need on it, but I still need my sort now, okay? So what I'm going to do before I do anything else, I've got enough code in here doing enough things. I want to check and make sure I don't have a typo or something while I've got just this little amount of code. That way I can catch it early if I do. So I need to run this. And it's got to redo its stuff to the original, okay. And down here, okay, we have list in original order, and it's still in the original order because we haven't done a sort. It would be nice to have a blank line after 25 and before this next comment. So I believe I'll fix that right now. And on this second print, right there, I wish to drop down a line, and we do that with the \n. And run it again just to make sure. And scroll this up so I can see. And yeah, okay, good enough. Now all I've got to do is actually do the sort. Okay, so we'll do the sort. That's Eclipse is being funky. That line doesn't belong there. All right, so now then I'll do public static void bubble sort. So public static void bubble sort. And again, when I call bubble sort, I'm handing down the list. The list is actually the memory address of where the array is started or located in memory. So I'll say, okay, I'm expecting the address of an integer array, and I will call that, it doesn't matter, I'll just call it values again. I could have called it list if I wanted to. But I like when I'm doing these demos to use a different name there, just so everybody is aware you can use a different name there. Okay, and then I'm going to comment, this one is the standard bubble sort, which is, there's improvements that can be made. Okay, so I'm just leaving that as a comment. So yes, I'm aware there's improvements that can be made. All right, now then. In this case, I actually have the running code off to the side here, so I don't have to fumble around trying to remember everything. Okay, let's see. All right, so we're back to, where were we there? All right, drop down a line. Now, the first thing I want to do is set up a loop that will go through the cards as many times as there are cards. So if I had 5 cards a while ago, to make sure it was in order, I had to go through it 5 times. Now, like I said, halfway through, it turns out, oh, we're already done. Well, the standard bubble sort doesn't know that. To guarantee everything is in order, you do it 5 times. Well, in this case, we have 10 cards, and we want to do that 10 times. And if it was 20, we'd want to do it 20 times. So I'm going to set up the code so it'll handle whatever size array it's given. So I'll say for, again, I'll reuse x equals 0, semicolon, x less than, I think I'll put a space around that, make it a little more readable on this one, x less than the length of the array. So if I've got 10 in there, I'm going to do this 10 times. So that will be values dot length. And I want to have x go up by 1 at the end of each loop. Okay, now here's what I want to do. For this time through the loop, I want to go through all the cards. Now remember, the outer loop says we got 10 cards, we're going to do this 10 times. What are we going to do 10 times? We're going to go through the cards one at a time, comparing each card against its neighbor, see if there need to be a swap, then move up one, and just keep working that way. So at this point, I am now trying to work my way through all of the cards. So this will be another for loop, and it'll be for int, this case I'll use y, and it will be y less than values dot length, same thing. Okay, almost. Okay, minus x plus 1, and I'll tell you why here in just a second. X plus 1. Okay, that's the condition. You figure all that out to see what your ending value is. And at the end of each loop, have y go up by 1. Okay, so let's see what that's going to do. Where is it? Oh, this is equal. I put a plus sign. Okay, so this will be my first time through the cards. And on the one I demoed for you that you could watch was just 5 cards long. Okay, so starting with y at 0, go until y is no longer less than how many ever cards you have minus x plus 1. Well, what's x right now the first time through the loop? 0. So x plus 1 will be 1. So this says go all the way through the cards less 1. And if you remember, when you get to the last card, there's nothing to compare it to. So that's where you want to stop. Okay, so inside this loop, then for each card, we're going to compare it to the neighbor, swap if necessary, move up by 1. That's Y moving up by 1. Go to the next one, compare it to its neighbor, if necessary, swap, move Y up by 1, and keep going until you get to and have worked with the next to last card. And when you have, then the next to last card will look at its neighbor, which is the last card, and do the swap there if necessary. All right, so we have gone through this once. We come back around to X. X is the one that's making us go through the whole thing as many times as we have values up there. Okay, so now then X is 1. We drop back into the Y's for loop, start Y over at 0. And this time we're going to go all the way through until as long as Y is less than the length, which in the code, there's 10 numbers. So that's 10 minus X is now 1. 1 plus 1 is 2. And that means we're going to go through the whole deck minus the last 2 cards. And if you remember, the last one I look at will look at the next to last card, but the very last card won't be looked at again. And the reason for that is we already know that last card is the highest card that was there. And so now then we will have run all the way through right up against that last card. And at the very end, we'll swap if it's necessary. And now then we know that the last 2 cards are the last 2 largest cards in order. So we drop out, we come back around to X. X is now 2. We start Y over at 0. This time we'll do Y as long as it's less than 10 minus X is 2. 2 plus 1 is 3. So we ignore the last 3 cards. Why? Well, the last 2 cards are the largest 2 in order. The next to last card, or well, the third card back, now doesn't need to be compared against the next to last or the last, because it's got to be, it can't be any bigger than it or it would already be up there. So on this one, you want to compare all the way up to the 4th card and the 4th from the end. And the 4th from the end will compare itself against the 3rd from the end. And then those will swap if necessary. And so the next time on your X loop, you look at 1 less card. The next time on your X loop, you look at 1 less card, because every time through, you're stacking another largest card to its place towards the end. Now, I haven't done the swapping yet, the comparing and the swapping yet, but how are you doing so far as to how this is supposed to work? Y'all give me some verbal. Don't make me bring out the exclamation point.
I guess I have a question about it.
Please ask.
Why exactly, like, how is this different from doing a sort that just, well, okay, I don't know. I just am a little confused as to why we have 2 for loops instead of having one that goes through every single one and then just until you find the end result.
Well, that is what we're doing, but to do that, it does take 2 loops. The outer loop just says how many times you're going to ruffle through the cards. The inner loop says, okay, as I'm going card by card by card by card, I'm going to be swapping where I need to. But just once through the cards, swapping where you need to doesn't get it in order. So
Okay.
You got to back up and do all that swapping again. The only thing one pass through the cards, swapping them like we're doing, the only thing it guarantees you is the largest card that was left is now at the end.
Okay.
Okay. So one time through 10 cards, well, we know we've got 1 card in the right place, don't have a clue about the other 9. So we do it again. Now then we know about the 10th and the 9th card, but not the other 8. And that's why it requires two sorts. And one of the best things you can do is do like I did to start with I had cards. If I would have thought while I was up at my office, I would have got all my dice that I've got up there, and we could have used those and put them in order. But you really do need to physically do this with something, okay? And follow your code. Your list is your cards or your dice or whatever it is that you've got out there that are not in order. They're just random. And then go through this code going, okay, I'm going to start through the list. Here's my first time through. Now then I've got to do, that's X. This is my first time through. Y is I'm going to go through and compare each card against its neighbor doing a little swap. Okay, and then look and see what you got. And when you look at it, then you go, well, no, this isn't through. Okay, go around to X and let X have, okay, so that means we got to go through them all and swap them again. And I'm doing these greatest illustrations with my hands on my desk. It was beautiful. Wish you could have seen it. Okay. These are the questions you should be asking. Okay. Well, I'll put it this way. These are the questions I asked when I first started working with this thing. I eventually just gave up and copied the code and said, I'll figure it out someday. And someday I did, but I'm trying to help y'all get it now. All right. So what I want to do, what's left now, is actually the work that goes on as I go from card to card to card to card to card. So this is what I'm going to do. Right now, Y is 0. Okay, so I'm going to say if values, which is all 10 numbers, sub 0, which is the first card or number or whatever you've got. Okay, if that happens to be greater than the one next to it, and the one next to it is that. Okay, if that's true, we got to swap them. Okay, now a lot of people will build a swap function for this, and that's kind of fun if you want to do it, but there's only 3 lines of code in this swap. Okay, remember, it's always of the format. We've got 3 memory places, A, B, and C, and we're trying to swap A and B. Okay, C equals A, B equals A equals C. That's how it works. So I'm going to call one of them temp. Okay, that's going to be C essentially. Is going to be equal to the first one. Okay, and that's just a command. Okay, I have duplicated that value in temp. Okay, now then, I'm going to say where that value was, which is values sub Y, is going to become equal to values sub Y plus 1, the one that's next to it. Remember, we're only doing this if the first card's bigger than the second card. Okay, now then, when I do this line 32, which is kicking at me, and I don't blame it, that's a mess. Just say, let me fix that. Okay, do this close, and then do this close. And okay, now then. All right, so as soon as I execute this line 32, whatever was in values sub Y has been destroyed. We would not know what used to be there if we hadn't saved that off into temp. And at this point, at the end of line 32, values sub Y is equal to values sub Y plus 1. They're duplicates. Okay, so now then I want to take what used to be in values sub Y and put it in values Y plus 1, which will complete the swap. And so to do that, I say values sub Y plus 1 is going to be equal to whatever I put in temp. Okay, and that's all there is to the swap. And that's all there is to the sort. Okay, so the X says we're going to do the innards of what's in this for loop as many times as there are values in the array. Okay, so how many values are there in the array? 10. Well, that's how many times we're going to do this. Okay, now then, I'm on first loop of X. X is 0. for this first time through, I have to check every card against every other card all the way down the line, swapping when I should swap. After I have done that once, only guarantee is the biggest card is at the end. Come back around. X is now 1. That little minus X plus 1 thing lets us look at 1 fewer cards every time through X loop. So the first time through, we looked at all the cards. This time through, we'll look at all the cards less 1. Next time, it'll be all the cards less 2. Next time, it'll be all the cards less 3. And all we're doing is just taking a card, comparing it against its neighbor. If the card we've got is bigger than the neighbor, swap them. If not, leave them alone. And that's a bubble sort.
I think you might have a typo on line 29.
Ah, impossible.
The value's at 0 instead of it being Y.
Well, yeah, that would really screw it up. And, oh, my notes are correct. That's good. Okay. All right, so let's go fix that. Y'all see why I don't code much before I try to test run what I've got. Okay. Hey, by the way, let's do this. If I leave that at 0, okay, that's wrong. Everybody good that's wrong. It should be whatever the value of Y is plus the 1 next to it. Okay, so this is a typo. Let's run it. It should run okay, but it should give us bad results. So let's find out if it does. So I'm going to click on run. And it's not in sorted order. It just didn't work. Okay. So let's correct that. And this will be one of the things that drives you nuts with this stuff is you don't catch that you did that. And luckily for me, I'm sitting here with, I lost my count, over 10 to 15 people watching me. And so it's nice that people catch that and I don't have to figure it out later. Okay, so I've corrected that mistake. Let's run this again and see how we do. Okay. Looky there. Y'all see a problem?
It's not actually sorting it, it's just taking the same original value and not doing anything with it.
You
I
got
think
it?
you still have bubble sort as a comment.
Oh, you know, that could do it. Reason it's not working, we never called it. Okay. Let's try again. And so that means we didn't really see what would have happened with the 0. I'm going to get it to work and then I'll go put the 0 in there. Now then we got it.
With
Yeah,
the
I'm
0,
gonna
it doesn't
bother.
sort. I tried it.
Okay. You already tried it. What it do?
It just doesn't sort because it's checking the original value, which is 1 in the list, and 1 is never going to be greater
Right.
than the rest of the other values.
And that's exactly what's going on. Let me run it for funsies. Oops, I've got the insert off. Okay, and let's see what that does. It should still just be all screwed up like it was. And it is. Did anything get changed out? Nope. It didn't. Now, if my original number had been something else, such as if this had been 171, I think that's now the largest number. Okay, so let's run it again and see what it does like that. Well, it made some shuffling difference, but yeah, it's not going to be right. That's the thing. And a lot of times when you get spurious results like that, it's going to be something as simple as one little keystroke that's off. That's why you want to have other people look at your code. All right. Are we good with this?
Yeah.
Okay. All right, then I'm going to go ahead and stop the recording.